Continuing chapter 3.4, we are looking at example F3-10, page of 111. We have a force being pulled on this ring here at 300 pounds, and cables AB, AD, and AC are all holding whatever's being pulled down in equilibrium. Now for AD, we are given a 45-degree angle from the z-axis, a 60-degree angle from the y-axis, and note that that's going to be a negative y, and 120 degrees from the x-axis to AD. So that means it's going to be also in the negative, if you can think of it that way, or it's going to be 60 degrees negative or 120 degrees, whichever way you want to look at it. Here we have, let's use a different color on that. We're going to be looking at that force right there. So we're going to look at 60 degrees, but we can say the cosine of 60 degrees of AC is going to put this vector inside the xy plane. So we can multiply cosine of 60 times the cosine of 30, which would be in the y-axis for AC. So my approach on this problem is going to be to draw a free body diagram, get my position vectors. Remember that term, position vector, we covered it a while back. And we're going to use our equilibrium equations. So let's go ahead and draw a free body diagram. And we have tension AB, we have tension AD, and last tension AC. So we can draw that there, and we can say that this is 30 degrees and this is 60 degrees, and then we have all of our angles here. This was 45. If we continued my axis here, we could say that from here to here is 60, and then from here to here, that angle is 120 degrees. And last but not least, we have our 300-pound force acting in the negative z. Okay. So now that we have my free body diagram, let's go ahead and come up with our equations for each rope or each cable. So let's look at AB. AB is along the x-axis, so we can just say that AB, tension of AB in the I is all we have. Let's look at AC. Now again, this is what I was talking about. We have to put it in the xy plane first and then multiply it. So we say cosine 60 degrees, so now we put it in the xy, and then we're going to multiply by the sine of 30. Now we can say that x is negative. So this, remember, this is a negative x back here, so this TAC is going in a negative x direction, so I can say negative sine of 30 plus cosine 60 back into the xy plane times the cosine of 30, and that is in my j direction, and then plus sine 60 times, well, that's it, plus times sine 60. And we're going to multiply all of this times FA, well, let's call it tension AC. Tension AC. It's all equal to 0. Okay, so now we have AD. And since on AD we were given all of the angles to each axis, it's much simpler. So we can say that X is going to be cosine of 120 degrees the y, now look at our y is going negative. So this is going to be a negative 60. So this is a negative cosine 60 in the j. And then we have a plus cosine 45 degrees. And all of this is going to be multiplied by TAD, which would be 0. Remember, we talked about in the lecture about the sense of the vectors and which way they're going. So drawing a free body diagram and really looking at which way they are, the vector, the sense of the the sense of the vector in which way it's going. So this last part, so now we have done those two. So the last part we're going to do, so we're going to sum our forces in the x, sum my force in the y, and sum my force in the z. So I'll just label these 1, 2, 3. So if I sum my forces in the x, it's equal to 0. I've got ABI minus, remember, because negative sine 30 times cosine 60 on my calculator came out to be 0.25 TAC, and minus 0.5 TAD is all equal to 0. Now we don't have to put this I here because we know that we're in the x direction, so we can leave those out. So multiplying sine 60, I get 0.5. Oh, I'm sorry, cosine 120, I got 0.5, but it's going to be negative. So when you put that in your calculator, it is a negative. Now sum my force in the y. Now, when I'm looking at AB, there's no j. So this would be plus j, 0j, and plus 0k is equal to 0. So 0j, so I'm going to go ahead and put that in there, 0 TAB plus 0.433 TAC. So that one there is going to be cosine 60 times cosine of 30, so that came out positive. And then I have plus, so this was negative cosine 60, which comes out to be plus, I'm sorry, that's going to be a minus, minus 0.5 TAD is all equal to 0. And my last thing I'm going to do here is sum my forces in the z, which I have TAD, which is going to be 0k, so 0 TAB. Now I'm looking for sine of 60, which would be plus 0.866 TAC, and then plus, I'm looking at cosine 45 times TAD, which would be 0.707 TAD minus, now let's not forget the 300 pounds that we're looking at, so minus 300 in my z-axis is equal to 0. Now, we can also, I'm going to go ahead and cheat a little bit. I'm going to just scratch this out. And then I'm going to say I'm taking this to the other side, so that's going to equal 300 pounds. So if I'm looking now, I can solve for my tensions in some of the cables. So let's just take a look real quick. I could do a matrix of 3 by 3, but I can also say, well, that's gone and that's gone. So I could solve for TAC and TAD by using a 2 by 2 matrix. So I'm going to set that up. So I have 0.433 TAC. Well, I'm going to take the TACC out of there. So that's TAC. And then I'm going to say 0.866 minus 0.5 plus 0.707. And then I have 0 and I have 300. And this would be TAD. So this would be A and this would be B. So when I put this in my calculator, I'm going to get the tension of AC is equal to 202.9 pounds, and then TAD, which is going to be 175.7 pounds. Now I can substitute this into equation 1. So I can come in and say that TAB is equal to 202.9 pounds times 0.25. Now, why did I make this positive? Well, because I already took these to the other side. So I went ahead and cheated a little bit. I said, all right, 0.25, take it to the other side, 0.5, take it to the other side. So now it's positive. Plus, since both of these are negative, both of these would be positive down here. 0.5 times 175.7. So TAB would then equal 139 pounds. So now we've taken what we've learned before in solving for our position vectors, and now all we're doing is we're using our equilibrium equations to work and solve for unknowns such as the tension tensions in a cable or a rope. So I'm going to do one more example. If you have questions, please go ahead and put it on the discussion page. Thank you.